Hello everyone. This is a video on differentiation of implicit function. One of my student has requested me to make a video on this topic. He is having difficulty understanding this topic. So let's start. If the variables x and y are connected by a relation of the form f of xy equals to 0, that means the function is combination of x and y. And it is not possible or convenient to express y as a function of x in the form y equals to phi of x, then y is said to be an implicit function of x. See, here we cannot separate x and y separately. We cannot write y equals to some function of x. So this type of thing is known as implicit function. Now, if we see the simple example, we want the derivative of sine of y with respect to x. See, here the function is of y, but we are differentiating with respect to x. This type of question or the format is known as implicit function. Here, what we can do, we can write the thing something like this into dy by dx. If dy cancel out, it would become the same thing. So what is the derivative of sine of y? That is cos of y and dy by dx. But many times we do not write like this, because when we are expert in this topic, then we can directly write in this format. That is, differentiation of sine y is cos y and differentiation of y is dy by dx. Okay. Now let us see some problem regarding implicit function. This is your first problem. So this is your first problem. Let's say if x root under of y 1 plus y plus y root under of 1 plus x equals to 0 and x is not equals to y, prove that dy by dx equals to minus 1 by x plus 1 whole square. Okay, this is your problem. Now let us see the solution of this. See, here the function is this x of this. Now what we can do, we can separate or take the y term, y of root under 1 plus x in the right hand side. So it will be minus y of root under 1 plus x. Now square the both term. It will be x square 1 plus y, square root and square cancel out, equals to y square into 1 plus x. Okay. Now this is x square, this is y square into 1 y square. Take it in the left hand side. So it will be x square minus y square, and it will be y square x, and here x square y, taking it in the right hand side, x square y. Now this is a square minus b square format. So this is x plus y into x minus y, and take minus xy common from this. So it will be x minus y. Cancel the term x minus y. It will be x plus y equals to minus xy. Okay. So x is equals to minus y minus of xy, or y equals to, taking y common from here, y equals to minus x by 1 plus x. Here we have separated the form. Now we can differentiate dy by dx equals to minus, we can apply the method u by v rule here. So it would be 1 plus x square, and derivative of x is 1, keeping 1 plus x minus upper term derivative of lower term, that is 1 is 0 and it is 1. Differentiation of x is 1. Okay, so after simplification we will get this will be minus 1 by 1 plus x square. It is the required proof. Now let us see another question. This is the second question. If sin y equals to x into sin of a plus y, prove that dy by dx equals to sin square a plus y by sin a. Okay, here we can simply see that we cannot separate x and y. So, and the derivative is given dy by dx. So when you will differentiate both sides with dx, you see here is one term is there, sin of a plus y. So first term, so this is in the form implicit function. First term dy by dx sin of y equals to ddx of x into sin of a plus y. Okay, now differentiate this. Differentiation of sin y is cos y, and differentiation of y with respect to x is dy by dx. Here we have to apply u into v rule. So differentiation of x is 1, keeping sin of a plus y as it is, plus keeping x, and derivative of sin of a plus y is cos of a plus y, and derivative of a is 0 and derivative of y is dy by dx. So it will be dy by dx. Okay, now let us rearrange the term. It should be cos of y into dy by dx minus x cos of a plus y into dy by dx equals to sin of a plus y. Okay, now taking common dy by dx, so it would be cos of y minus x cos of a plus y into dy by dx. It should be sin of a plus y, or this should be cos of y minus, see, we have sin of y equals to x sin of a plus y. This relation has been given. Now what is x? X is sin of y by sin of a plus y. Okay, so we can put this thing here, sin of y by sin of a plus y into cos of a plus y into dy by dx equals to sin of a plus y. Doing LCM, this would be sin of a plus y into cos y minus sin of y into cos of a plus y divided by sine of a plus y, this is in the bracket, dy by dx equals to sine of a plus y. Okay. Now, this is the form of sine of a plus b. Sine a cos b minus cos of minus sine a cos b minus cos a sine b. This is sine of a plus b, or sine of a plus y minus y. This is sine of a minus b. Sine a cos b minus cos a sine b. Sine of a minus b by sine of a plus y into dy by dx equals to sine of a plus y. So this y and y cancel out. This should be dy by dx equals to, this sine term would be cross multiplied here, sine of square a plus y divided by sine of, this is the thing we have to prove. Now let us see another problem here. Here, if y equals to cos inverse root under of this thing cos 3x by cos cube x, then show that dy by dx equals to this root under 3 by cos x cos 3x. Let us see the solution of this thing. Here y equals to cos inverse root under cos 3x by cos cube x, right? Taking inverse term in the left hand side, it would be cos y equals to root under of cos 3x by cos cube x. So here we have to apply the formula of cos 3x, that is 4 cos cube x minus 3 cos x by cos cube x. Dividing by cos cube x, we will get cos cube x will cancel out. So this will be 4 minus 3, and here 1 cos will cancel out. So 1 by cos square x, that is sec square x. So 3 sec square x. Now squaring both term. So both side, it is cos square y equals to 4 minus 3. In place of sec square x, we can write 1 plus tan square x. So this would be, here 4 minus 3 is 1, and if you take cos square term in the right hand side and this term in the left hand side, so this would be 1 minus cos square y equals to 3 tan square x. So this is your sine square y, 1 minus cos square theta is sin square theta. Here it is 3 tan square x. So sin y would be root 3 tan x, taking square root on the both sides. Here, take differentiation on the both of side with respect to x. Then we can say differentiation of sin y is cos y, and differentiation of y is dy by dx. Root 3 is constant, and differentiation of tan x is x square x. So here dy by dx would be root 3 by cos y into cos square x. X square is 6, 1 by cos square x. So this should be root 3 by cos square x into cos cube x by cos 3x. See, here we have applied this relation because we know cos of y equals to root under of cos 3x divided by cos cube x, right? Here we have applied in the place of cos of y. Okay, done. So our next step would be dy by dx equals to square root of 3 divided by taking the cos square x term into the square root. So it would be cos x, and 1 cos x will cancel out. So here we'll have square root term, so it would be cos to the power 4x. So cos cube x and cos cube x will cancel out, and here we will remain with 1 cos x and cos 3x. This thing we have to do. Okay, so I think you have understood the topic implicit function. Have a good day.